Okay, take a look at this scenario here. We're going to fire a cannonball on Mars, and gravity on Mars is this. We're going to fire it at 15 meters per second. Normally, well, I would ask you find out the height. Uh, find out. Well, it will get to its maximum height here, and then it will free fall. Find out the height after. I don't know. After let's say 6 seconds. Okay. So you would jump to your velocity time graph. Let's say it's this here. Okay, hang on. So you would draw your velocity time graph like this. Velocity time. Okay. You would come up with an equation for this line here, which would be v equals this, and then the most important part is this bit here. You want to find out the time it takes to get to its maximum height here. Okay, and it just so happens that well, it would be 15 divided by 3.71. Okay, that will give you the maximum height, the time to get to the maximum height, which in this case will be 4.04 seconds. So I would ask you something like this. Oh, find out the height above the ground when it's at, let's say, 6 seconds. So you see, I conveniently choose a time that's just beyond the maximum the time to maximum height. So I would ask you to find out the height here. In which case you would find out the maximum height, which will give you this area here. Okay, and then I would ask you to jump to the free fall formula, h equals gt squared over 2. You see, this distance here is actually the same. It's actually the same as this area here. So when I say, oh, get the maximum get the maximum height, which is this area here, and then take away this distance here. Well, this distance here is actually the area here. So this is 6 seconds. Yeah. So I would say get this area here, take away this area here, and then that would give you this height here. Okay. Now suppose you want to find out. Let's say time t equals 1 here and t equals 3 here. Okay. Hang on. This is 1 here and this is 3 here. Let's say, oh, and this point here is 4.04. Let's say you want to know. So when you fire the cannonball, let's say time equals 1 is here, t equals 1. Okay, t equals 2 is here, t equals 3 is here. Now let's say you want to know the distance traveled between t equals 1 and t equals 3. So in which case you would do this here. You would need to find out the area of this trapezium here. Now to do this, you need to know this height. Well, this height, well, put 1 into this equation here, and then it will give you v. That will represent the height. And then get this height. Put the 3 into the t here to get this height here. Now, then to find out the area of this trapezium, you get the height here, plus this height here, divided by 2 to get the average height of the 2, and then times the across. The across here is, well, if it's 1 second here, 3 seconds here, the across here would be 2. So that's how you would find out the distance traveled between t equals 1 and t equals 3. Okay. Now, suppose you want, let's say we want to find out, let's say we want to find out the distance, the height above the ground after 6 seconds. Okay. Now 6 seconds. Let's guess 6 to be around here. So 6 seconds here. Now, when we use a trapezium for this, you would get this height here, plus this height here, divided by 2. That will give you the average here, and then you would times the across here. Now, even though 6 is over here, the trapezium rule still works. I know this seems strange here because get this height plus this height here. Well, this will be a negative, don't forget, because when you put 6 into here, it will be a negative. it will be a negative. So this length here will be a negative. All right, let's put it in here. So it will be this point here will be v equals 15 take away 3.71 times 6. Okay, so let's jump to a calculator. Clear this. So it would be 15 take away where's my bracket? Take away 3.71 times 6. Hang on, let me do this again. Because I know this calculator well, I don't actually need the brackets. It will still work. But on your calculator you might. Okay, 15 take away 3.71 times. No, it doesn't work on this calculator. All right, I'm going to have to do 3.71 first times 6. I hate this calculator. Times 6, and then it would be 50. Hang on, let me do this one step at a time. 15 take away 22.26. Now get 15 take away 22. So hang on, clear this. So now get 15 take away 22.26 equals this. You see, the answer is a negative number, negative 7.26. So this distance here, this length here is negative 7.26. Now, because we're trying to find out the height above the ground after 6 seconds, so we want to find out this height here. We need to work out this area. Take away this area. You see, this area turns out to be a negative anyway. So when you add up because this is a positive area, this is a negative area. When you add up the two, it will automatically get this. Take away this. Okay. So hang on. So if you want to know the distance, the height here, all you have to do is again use the trapezium rule. Normally, hang on. Let me clear this. Normally, if you want to work out the time travel between, let's say, 1 and 3, you would get this plus this divided by 2 and then times it across here. Now here, we would want this plus this. This will be a negative, but it still works. So this, which is 15, plus this distance here. What was it earlier? I can't remember. Minus 7 point something. Okay. And then divided by 2. That would give us the average height. Let's say around here. And then times by the whole distance, but this whole distance here, which, well, this whole time here, the length of time here, which is 6. So times 6. So this whole thing here will give us the actual height above the ground. Okay. I know it seems weird. Just the important thing is when you have the trapezium rule, you get this plus this divided by 2 and then times it across. The important thing is, even though it's a negative down here, the trapezium rule still works. So if all you have to do is get this height plus this height here, and then divided by 2. That will give you the average of the two, which is probably somewhere around here. Okay, and then you times this length here, and it will still work. Okay, in the next video, you can see it for yourself. Okay.